Welcome to this tutorial, and the subheading is conservation of linear momentum. In conservation of linear momentum, let us first understand the principle of conservation of linear momentum. Principle of conservation of linear momentum. So, the principle of conservation of linear momentum, it states that the total momentum of a system of masses in any direction remains constant unless acted upon by an external force in that direction. This is what it means. When we had got a body of mass m1 and a body of mass m2, first, this body of mass m1, it will remain constant in that direction unless acted upon by an obstacle. When an obstacle hits it at this point, it may stop or it may change direction. So that is why the principle of linear momentum states that the momentum of a system of masses remain unchanged unless acted upon by an outward external force in that direction. And the formula of momentum is just the product of mass and velocity. That is a simple definition of momentum. Product of mass and velocity. So you can write momentum equals to mass times velocity mv. Then let us assume we had got this body of mass m1 and another body here of mass m2, and this body was in motion while this other body was at stationary or at equilibrium. Now, when a body is at equilibrium, the forces acts on it, but the forces that acts on it make it at a constant level. The forces holding this body is equal, so it is at stationary. So the momentum of this body, since it is in motion, is m1 u1. When it hits this body, which was initially at a stationary level, the body will either move on its own or they will move together. And there we are going to learn of two collisions. We have got elastic collision and inelastic collision. So here, in elastic collision, when a body hits a stationary body, they don't become in contact. There is no contact here. No contact when a moving body hits a stationary body. Both the bodies, they may either stop on their own or they may move on their own. But here in elastic collision, whatever I want you to understand, that after the body hitting one another, or after the bodies colliding, they will be in contact and they will assume a common velocity. So, having a body, two bodies, let me say two bodies, M1 and M2. At first, their momentum, the initial momentum is M1 U1 plus M2 U2. This body was moving with a velocity of U1, and this one, it is at stationary. So their initial momentum is M1 U1, then M2 U2. This means the momentum of the body of mass M1 plus the momentum of a body of mass M2. Then, when they collide in a perfect elastic collision, after collision, the bodies doesn't move together. Each will move on its own. So there we say M1 U1 plus M2 U2 is equals to the momentum after collision. There, so we write M1 V1 plus M2 V2. Even after collision, each body will assume its own velocity under perfect elastic collision. But to synchronize this, or to simplify it, we know this body M2 was initially at rest, so meaning it had got a velocity of 0. It was not moving. So this implies that M2 times U2 here will remain 0. So M1 U1 is equals to M1 V1 plus M2 V2. And here note that if the body of mass M2 was at rest, so when this formula implies, but when the body was the two bodies were moving initially they was moving, and M1 was moving at a higher rate than M2, they will still collide. But in that case, this formula will remain, since U will not be 0. So this formula will remain. Then, I also want you to understand perfect inelastic collision, or just inelastic collision. Here, we are not actually interested in definition, but understanding the key concept under this point of inelastic collision. Having two bodies of mass M1 and M2, then M1 was moving at a velocity of U1, the initial velocity, while this was at rest. So we know that In principle conservation of linear momentum, the momentum before collision equals to the momentum after collision. Momentum before is equal to momentum after. So in this case, in elastic collision, the bodies will move together after colliding. They will move in contact. So here the formula we use, momentum m1u1 plus m2u2 is equals to m1 plus m2 times v. This implies that after the bodies colliding, they will retain their state of collision, that is, they will be in contact with one another. Mass 1 will be attached to mass 2. And after being attached to mass 2, now that system of mass of bodies will assume a common velocity v. That is what it implies. And to simplify this formula, at this condition, let's say the first condition which we said m2 was at rest, meaning u2 was 0. So m2 u2 will be 0. So that is m1 u1 equals to m1 plus m2 multiplied by v. Then you know that this condition is when m2 was at rest. But when m2 was also moving, a condition where both bodies are moving now. Meaning m1 is moving, m2 is also moving with a velocity of u2, and here with a velocity termed as u1. In this case, the formula will remain. That is momentum after collision of body of mass m1 plus momentum after collision of body mass m2 will be m1 plus m2 multiplied by v. Here the condition is both bodies are moving. Hopeful that the video has helped you. Please don't fail to subscribe into the channel or to like the video. See you in our next video.